Good morning, students. Dear students, as before, we had completed our chapter 5th, that is laws of motion, and in that we had discussed all the concepts, numericals, free body diagram, friction, all these things we had discussed in that chapter. Now, today we will start our new chapter, that is chapter 6, that is work, energy, power. Till that chapter, in unit test first, it is coming, the questions in the unit test first is coming till this chapter, that is chapter number 6. So, now let us start our discussion on the chapter, that is work, energy and power. So, students, all the three physical quantities you are knowing, you had studied about work in previous classes also. The same thing is here, little bit extension of that. After that, energy also you had discussed. Some more things is added here, and power you had also discussed. You had also studied in class 9. Something more added here, and all things are very much interesting and related to your day-to-day life. So understand this chapter very carefully and try to grasp all the concepts. Watch all the videos. Now, as per the deleted portion, in this chapter nothing is deleted. As previous, the contents of the chapters, the same content of the chapters this year also. So, now we will discuss about work. What is work? In daily life, you come to know about work various times. You used to say the term work, and work is nothing what you physically do or mentally do throughout the day is the work. But in the sense of physics, certain works you are doing the physical work, but it is not considered as work. You are, suppose a person is carrying the load on over his head and moving in the forward direction, then in physics we say that the person is not doing any work. Similarly, whatever the mental work you are doing, mental work is not considered as work in the physics. Means in physics, the work is defined as when you apply the force on a body and there is displacement in the direction of the force applied. If you are applying the force on the body, if in physics, I want to say that if there is a body of mass m and you had applied force F on that body and the body displaces itself in the direction of applied force, the body displaces itself, then only you say that the work is being done on the object. If the force is applied in the downward direction, if the force is applied in upward direction or downward direction and the body displaces in this direction, then no work is said to be done in this case. In spite of the fact that the physical work is done by the object or the body, but physics says that no work is done in this case. So let us discuss the definition of the work. So work is said to be done. So we can say that work is said to be done on an object if a force is applied on the object, force is applied on the object and the object and the object moves in the direction of applied force, moves in the direction of applied force, moves in the direction of applied force, then only we can say that work is being done on the object. So dear students, work is said to be done on the object if two conditions are satisfied. Two conditions are satisfied. Only these two conditions are satisfied, then it is said that work is done on an object. First is force is applied. Force is applied in the direction of force is applied in the direction of displacement, and the second thing is first condition is satisfied that force is applied in the direction of the displacement, and second condition is the displacement, we can say that the force is applied on the object. First condition is force is applied on the object, and second is the displacement is in the direction of applied force. These are the two conditions. Then we can say that the work is being done on the object. You had already studied about all these things. Now, the examples of this is when the engine pulls a train, or when you are pulling a lawn roller, then one component of the force is along the direction of the one component of the force is along the direction of the displacement, and in that case we can say that the work is done. Now we will discuss about the work done by a constant force. Work done by a constant force. Work done by a constant force. Work done by a constant. Work done by a constant force. Work done by a constant force means, suppose this is the object of mass m placed on any surface, and a force F throughout the displacement of the object on this surface, the force F acts. The force F is not going to vary with time, it is constant. Suppose you are applying the force of 10 Newton, then throughout the displacement of the object, the force applied on that object is of 10 Newton. So, if the body displaces a distance s by the application of this force, then the work, since the displacement and the force are along the same direction, so we can say that work done on the object, that is W is equal to applied force, that is F into displacement that is displacement S, and you can say that F force into displacement, since the force and displacement are along the same direction. So you can say that the force work done by the constant force is the force acting in the direction of the displacement, and it is the product of the force and the displacement. Now we will discuss when the force is inclined at an angle theta. When the force is inclined, work done by the force, work done by the force inclined at an angle. Work done by the force inclined at an angle. Suppose this is the object of mass m. This is the object of mass m, and a force F is applied which is inclined with the horizontal at an angle of, which is inclined, force F is applied which is inclined at an angle of theta with the horizontal, and by the effect of this force the body displaces in this direction. The body displaces in this direction. Let us suppose this displacement is S. Now here, force is a vector quantity. You know that the force is a vector quantity. So this force F can be resolved into two components. First component of the force is Fy, and the second component of force is Fx. Now Fy is the vertical component and Fx is the horizontal component of the force. Since body does not displaces in the vertical direction, since the displacement of the object is not in vertical direction, since displacement in vertical direction is 0, so work done in the vertical direction, that is Fy into displacement S is equal to 0, and it is equal to 0. So there is no any displacement in the direction of the vertical component of the force, so work done is 0. Now the body displaces itself in the horizontal direction of the applied force, but the body displaces in horizontal direction. Displaces in horizontal direction, since the body is displacing itself in horizontal direction. So work done is equal to Fx. Fx is the force in horizontal direction, component of the force in horizontal direction. So Fx into S. Fx into S. And you know that the component Fx is called as F cos theta. Rectangular component we had discussed or we had studied, and this is F sin theta. So we can write it as Fx as F cos theta into S, and now we can write from here W is equal to F S cos theta. W is equal to Fs cos theta. And since you know that in vector you had studied the force and displacement both are vector quantity, so we can express work done as the dot product of these two vector quantities. So W is equal to vector F dot vector S. W is equal to vector F dot vector S, and dot product can be written as Fs, cos magnitude of force vector into magnitude of displacement vector, and it is equal to Fs cos theta. Now look here students. This is the dot product of two vectors. This is the dot product of two vectors. And you know that dot product is also called as a scalar product. Dot product is called as a scalar product. So work done is a scalar product. So we can write from here. So work done is a scalar. Work done is a scalar quantity. That is dot product of two vectors. Dot product of two vectors. It is dot product of two vectors. So work done is said as, or work done is referred as the scalar quantity. It is the scalar quantity. Now, dear students, we will discuss about from this case, Fs cos theta, we will discuss about when the work done is maximum and when the work done is minimum. So these two cases you know, I think you know it also, but also I am, after that also I am discussing here. Now, first case students, we will discuss. Dear students, first case, when force and displacement are in the same direction, that is theta is equal to 0. When force and displacement are in the same direction, force and displacement are in the same direction, that is theta is equal to 0 degree and theta is equal to 0 degree. When force and displacement are in the same direction, so we can write it Fs, W is equal to Fs cos theta, and W is equal to Fs cos theta means Fs cos 0 degree, and you know that cos 0 degree, the value of cos 0 degree is maximum. At 0 degree the value of cos theta is maximum, so cos 0 degree is equal to 1, so we can write it as W is equal to Fs1, or force into displacement, that is force by the constant force we had discussed. And in this case work done is equal to maximum. In this case, the work done is maximum when the applied force and the displacement is in the same direction. And the case second, we will discuss when the force and displacement are perpendicular to each other. When force and displacement are perpendicular to each other. When force and displacement are perpendicular to each other, that is theta is equal to 90. You had seen this case. Suppose I am saying that this is a tabletop and this is an object placed on the tabletop and you are pulling that object, then the object displaces in this direction. Means whatever the force you are applying in the horizontal direction, the all forces are involving into the object for doing their work, and theta is equal to 0 degree. So in this case we can say that maximum work is done. Now if suppose there is a case, you had seen that at railway station your luggage are carried by the pulley and pulley holds your luggage on his head, and moves in the forward direction, then whatever the forces acting, whatever, suppose it is the pulley, it is the pulley, and he had hold the weight on over his head and moving in this direction, So the weight is acting mg in this direction, the weight of the object is mg in this direction, and the displacement is in this direction. So the weight and mg, the angle is 90 degree. This angle is 90 degree. So in this case, what is the work done? So W is equal to Fs cos 90 degree, and it is equal to F, and you know that the value of cos theta is minimum at 90 degree. So it is F0, and here the work done is equal to 0. Means physically the person is doing work here, but in sense of physics no work is said to be done, and so work done is 0, and here it is said that W is equal to minimum. W is equal to minimum. So these are the two cases. Now we will discuss about the dimension and the unit of work. So first of all, we will discuss about the dimension of work. We will discuss about dimension of work. Dimension of work. So you had stated that work is equal to force into displacement. Work is equal to force into displacement. Now dimension of work W is equal to force. Dimension of force, mass into acceleration. The dimension of mass is m, and acceleration, that is distance meter per second square, and lt minus 2 into displacement L. So the dimension of work is m L square t minus 2. This is the dimension of work. Now the unit of work. We will discuss about unit of work. Unit of work. So dear students, while discussing unit of work, you know that unit of work is joule. But here there are two types of units of work is defined, that is absolute unit of work and gravitational unit of work. So, two types of unit of work. First one is gravitational unit of work. First one is absolute unit of work. And second one is gravitational unit of work. Gravitational unit of work. First one is absolute unit of work, and second one is gravitational unit of work. So we will discuss both the types of work, that is both the units, that is absolute unit of work and gravitational unit of work, in detail. So let us discuss about, first of all let us discuss about absolute unit of work. First we will discuss about absolute unit of work. Absolute unit of work. What is absolute unit of work? First we will discuss about absolute unit of absolute unit of work. Now, dear students, what is absolute unit of work? So, absolute unit of work, whatever the work we will do without the help of gravity or without the help of gravitational pull, whatever the work we used to do without the gravitational pull, मतलब mechanically or physically whatever the work we do, mechanically or physically whatever the work we do is considered in absolute unit of work. And the work which is done by the gravitational pull or gravitational force is included, that is considered as gravitational unit of work. So absolute unit of work is first is joule, and it is absolute SI unit, absolute SI unit of work. It is absolute SI unit of work. In SI unit, we define the work unit of work as joule. Now, what is 1 joule? 1 joule of work is said to be done on a body if one absolute unit of force displaces an object by a distance of 1 meter. By a distance of 1 meter. Now, 1 joule is equal to 1 absolute unit of force, means 1 Newton. 1 Newton is the SI unit of force into 1 meter. So 1 joule is equal to 1 Newton. 1 Newton meter. 1 joule is equal to 1 Newton meter. Clear? As you know that W is equal to Fs cos theta. So if this force is acting in the direction of displacement, then theta is equal to 0 degree and S is equal to 1 meter and force is equal to 1 Newton. Then the work is said to be 1 joule. Then this work is said to be 1 joule. Now, the second this absolute unit of work is arc. Second absolute unit of work is arc. Second absolute unit is arc. It is the CGS absolute unit. It is the CGS absolute unit of work. CGS absolute unit of work. So 1 arc is defined as if one dyne of force displaces an object through a distance of 1 centimeter, through a distance of 1 centimeter. So we can say that W is equal to F as cos 0 degree. So it is equal to 1 time into 1 centimeter. So one arc of work is said to be done. It is equal to 1 dyne centimeter. 1 dyne centimeter. So 1 arc is equal to 1 dyne centimeter. That is absolute simplest unit of force. Now, relation between joule and arc. There is a relation between joule and arc. What is the relation between joule and arc? Look here, students. 1 joule is equal to 1 Newton meter, and you know that 1 Newton is equal to 10 to the power 5 time. 10 to the power 5 time, and 1 meter is equal to 10 to the power 2 centimeter. So we can write it as 1 joule is equal to 10 to the power 7 dyne centimeter, or 1 joule is equal to 10 to the power 7. 1 joule is equal to 10 to the power 7. 1 joule is equal to 10 to the power 1 joule is equal to 10 to the power 7 arc. 1 joule is equal to 10 to the power 7 arc. This is about absolute unit of work. Now we will discuss about the gravitational unit. We will discuss about the gravitational unit of work. So dear students, work is said to be one gravitational unit when one gravitational unit of force displaces the object by a unit distance. And what is the gravitational unit of force? The absolute unit of force is Newton or dyne. So gravitational unit of force is kilogram force, kilogram weight, gram force or gram weight. Kilogram force, kilogram weight, gravitational, note it down, gravitational unit of force, SI, kilogram weight or kgf, or CGS, gram weight or gram force or gram weight. So one gravitational unit of force, of gravitational unit of work is said to be done if one gravitational unit of displaces an object to a unit distance. Force, unit distance. So one gravitational unit of force is unit distance. So the first one is kilogram meter. Kilogram meter. It is SI unit of gravitational SI unit of gravitational unit of it is the SI unit of gravitational unit of work, and it is given as kilogram meter. Kilogram meter is the SI unit, and it can be defined as 1 kilogram meter. 1 kilogram meter is defined as if a force of 1 kilogram weight displaces an object by 1 meter. Displaces 1 kilogram weight displaces an object. So we know that W is equal to Fs cos theta, or theta is equal to 0 degree. Theta is equal to 0 degree. So we can write it as W is equal to Fs. We can write it as W is equal to F into S. So W is equal to 1 kg weight into 1 meter. 1 meter. And 1 kg weight can be written as 9.8 Newton meter. Means 1 kg meter is equal to 9.8 Newton meter, or 9.8 joule. 1 kg meter is equal to 9.8 joule. Now gram centimeter. It is kilogram meter, that is SI unit. Now second one is gram centimeter. Next one is second is gram centimeter. It is CGS, gram centimeter. Gram centimeter. Gram centimeter. And yes, students, gram centimeter, and it is nothing. It is CGS unit of gravitational unit of work. It is the simplest unit of gravitational unit of work, and it can be defined as when 1 gram force displaces an object. When 1 gram force displaces an object to 1 centimeter. When 1 gram force displaces an object to 1 centimeter. So you know that work done is equal to Fs cos theta. and theta is equal to 0, so it is equal to F into S, and force is equal to 1 gram force, 1 gram force or 1 gram weight into 1 centimeter, and 1 gram force can be written as 980 dyne into 1 centimeter, and it can be written as 1 gram centimeter of work is equal to 980 dyne centimeter, 980 dyne centimeter, and dyne centimeter, 1 dyne centimeter is equal to 1 earth, so it is equal to 980 earth. It is equal to 980 earth. So 1 gram centimeter is equal to 980 earth. This is the CGS unit of gravitational unit of work. Gravitational unit of work. So, dear students, this is all about the introductory part of the work, its dimension, its units, types of work. Now, in the next class, we will discuss about the types of work, that is positive work done, negative work done, zero work done, and we will solve 1 or 2 numericals based on this. So that's all for today, students. Thank you. Have a nice day.